Hi everyone, I'm Ben Cook. Over the last year and a half, I've built up WashU Satellite, an undergraduate design team at WashU, from zero to $250,000 of funding and 45 top engineers and physics students. And right now, I'm going to build Replication Scientific to try and solve some of these problems that I found with building these custom products and solutions to accelerate research. So first off, I need to meet my new friend Michael, right? Len was a researcher over at the med school, and he wanted to study heart tissue strength, right? He's one of our first customers. To study this, he wants to figure out how stretchy is his heart tissue, right? It's with this thing called a tensile testing machine. And all this is right, it's a sensor to figure out how much force is pulling on this. You need an actuator to move at a certain distance, and then a temperature valve to hold it constant. Unfortunately, this costs 38 grand, and they had to negotiate for a month. And this is a very common story, right? Our other, one of our other first customers, Professor Guy again, basically said, if you can make Amazon for lab equipment, I would buy literally everything from you. And it just speaks to the absolute need that researchers have for custom, high-quality equipment. But it's also not just researchers, right? If we look at industrial automations, there are these things called programmable logic controllers, or PLCs. And these, along with their accessories, are basically like the brains of factories, right? Unfortunately, the market is basically dominated by two big players, right? Siemens in Europe and Rockwell in America. And they charge about 20 times what it should cost, right? And they give a software that's incredibly, that's clunky, hard to use, and has bad licensing, right? One of my friends who's now working on this basically said, this is holding the American industry back. There's so much talk of American dynamism right now, and we're not going to deliver it because of the current solution that we're using. And then you have the same case with system integrators like Boeing and BAE, right? They're being massively disrupted by companies like SpaceX and Anduril because they can be vertically integrated and move fast. They need better subcontractors, right? They should not be waiting weeks, they should be getting in days. So this is what we're offering, right? We're going to help people move from requirements to reality 10 times faster. So it's quite a similar process, right? So you start off with figuring out what are you building, right? Define your system. So what does it need to do? What are the constraints? What are the environmental conditions it's going to be under? And then we'll show you a suggested form factor for it. And you can refine it from there. And then we take care of everything else, right? We'll go through all the actual design, manufacturing, validation, and then provide service for the life of the product. What we really do is we let researchers do what they do best, right? Which is do the research, not the engineering. So let's talk about markets, right? We're going to start off with SOM, right? We're going to focus on St. Louis, targeting academia labs which are supported by these NIH grants, as well as early stage startups and some producers who need R&D equipment. Then, we think that the best beachhead market for us is this North American lab equipment, which is a $10 billion market, which is growing pretty rapidly. But the real power of this is that it's going to fundamentally reshape how integrated systems are designed and built, and that's where we can really go after the $600 billion opportunity. This obviously will take years. So why now, right? This seems like a crazy opportunity, but this has never been possible before. If you look at what generative AI does, it's kind of like a translator between languages, right? You can talk between the scientist and the engineer language. Just that takes weeks off the lead time, because normally that's a negotiation process between salespeople and technicians and scientists, right? Additionally, we can simply develop our front-end design faster, because a key part of this is making this accessible to people. And if we can rapidly iterate on our design, we can make it more user-friendly. And then if we look at the hardware side, right, manufacturing, there's so much innovation happening in robotics right now. There's things that have never been possible before. So things like plugging one wire and putting it into a connector. That seems easy, but it's actually not. But now it has become possible. And then if we look at the actual electronics build itself, right? PC build has become 10 times faster, cheaper than before. And so the assembly machines, right? I can go and buy one for $2 grand. It used to be 200 grand, probably 10 years ago, right? So this business has never been possible to run at this scale before. And then additionally, look at the demand side, right? Like there's a massive push for domestic manufacturing, and because we can do that locally, we can hit their lead times and be fully sourced in America much faster. So let's look at the beachhead market, right? Researchers, they need us right now, right? If you look at their incumbents who are most important, like Thermo Fisher and Aurora Scientific, they're slow, they take optimistically weeks, pessimistically 2 to 6 months, and they have these horrible interfaces. With this product, this tensile test machines that our first customer had, it was fully locked down. They had a microchip they wanted to put on top of it. They couldn't plug it into their computer because they had to buy a new computer to plug it into, right? This is just unacceptable. And they're startups working on this side. We're working on like the software layer, in the integration layer. But the problem is they're still limited by the actual hardware piece of equipment. And that's why it's still slow. You can move faster if you just try and import things cheaply from China, which seems outrageous, but the big manufacturers are just so slow that they're still beat out on speed. And DIY with another startup like Opentrons. But the problem is that this leaves so much work to the user. And researchers are not engineers, right? They're scientists. And a lot of them cannot do this. And that's where we come, right? We can offer both speed and ease of use. And that's why we're such a powerful force in the research market. So, to talk about that, they don't just need us, they're already buying from us, right? We have 2 signed contracts with mechanical engineering and medical labs that we're already delivering on. And then we have a wait list of 2 more labs and 4 more local startups. At this point, it's, literally we've talked, these are 8 people here. These are 8 people in a row who wanted to buy from us. We haven't, since we landed on this thing, we haven't really heard a no from someone who we thought would be a yes, right? The things that I'm claiming that we've confirmed, right, is that they know what they need, but they don't know how to do it, right? And that's what they actually need. They need someone to tell them and just do it for them, because they'll pay for that. If it just works, it doesn't matter. They'll pay for reliability and ease of integration, right? So, I think that the point of this is, we understand what the right thing to build is. So then if we look at how do we go to market, right? We're going to start off with, this is a very complex approach, right? It was probably 10 steps in the value chain, all right? Which is very daunting. So what we're going to do is start off with things that are as simple as possible, which are just these sensor and actuator interfaces, and then move on to general auto test equipment, and then kind of go after the TAM. But the TAM is a future problem, right? This will let us go after the SAM, this will let us go after the SOM, I would argue, right? I think the key notes on this is that because we're automating the design process, every new thing that we add is going to give us this linear increase in engineering costs, this combinatorial effect onto the number of products that we can make, which is what allows us to go head to head with people like Thermo, without the billions of dollars of engineering investment, right? And then additionally, we're focusing on these very high margin sectors first, which we'll get to in the next slide, but that allows us to raise the funding to generalize this development, right? And I think the key thing to note is, and this is a very different approach to a lot of other startups, right? The problem of hardware is difficult is very obvious, right? To anyone who's built hardware. But most people are focused on building AI for electrical engineering, or building AI for mechanical engineering, and then making it as general as possible. We're saying, no, let's build the full stack and solve for the simplest possible case. And that's sensor and actuator. And our thesis is that actually builds a lot more value, even with a similar amount of engineering investment. I'm going to say actually some of this because I know we're bad on time right now. But let's talk about margins. So it's pretty ridiculous. It's soft margins on hardware. It's pretty insane. It's that because the actual bill of materials and the assembly cost, the calibration, the validation is not really what you're paying for, right? The reality is that you're paying for a brand name and you're paying for the non-recurring engineering expenses. That's what we can massively undercut on. Because we can automate all steps of the process, we can simply have far better margins than they do. Right now, this isn't the that we're doing. This is for our first customer, bless you. It's a pretty good margin. But as we can bring things in-house and sell these higher margin pieces of equipment, our margins go up significantly because the engineering gets even more expensive in the traditional sense, right? So then let's talk about what we want to do next, right? So right now, we are collecting data to de-risk our model. That's our main priority, right? We are not currently looking to raise funding. There's a couple sources of grant funding that we're working with, and we're still over the next 2 weeks we're going to see how much we can get, potentially the 50 grand range. But in about 1 or 2 months, we're going to raise a couple $1 million seed round. And sorry, this was made recently. That was research is wrong. So we want to do 3 things with it, right? We want to first off build a manufacturing line, and it has 3 benefits, right? Because we can integrate manufacturing within us, the lead times go down by a lot, right? Typically, a quick turn would be a 3-day PCB. If we can do everything internally, we can deliver it next day, which opens up massive new sales opportunities because our value prop gets so much better, right? Additionally, because of that, our margins get way better because we're doing it internally. And then finally, for the rate of development, because we have a much more rapid iteration pace, we can just expand to more products in a very aggressive manner. And the next big thing is, right, building out these partnerships, because we don't really know what the demand's going to look like. I mean, we have some projections, right? But reality is always different, and manufacturing is very expensive. So what these outsourcing partnerships allow us to do is, if we build a factory to handle this, we can just outsource as needed, and then take load and reconfigure our factory. Which is critical, because we don't want to be like, sorry, we can't hit demand, right? That's not a scenario that we want to be in. We think we're going to lose customers that way. And then finally, just establish a facility running, right? We're going to have about 18 months of facility costs and a team of about 8 to 10 engineers to actually deliver the future. So yeah, thank you so much.